All right, so today we're learning about graphing linear equations. The easiest way to graph a linear equation is when you start out with an equation that is in slope-intercept form. So let's remind ourselves, what exactly does slope-intercept form look like? Because it's been a while since middle school. All right, so slope-intercept form is any equation that is in the form y equals mx plus b, where m is your slope, and b is your y-intercept. And this is kind of how it gets its name, right? The slope-intercept form. All right. So we're going to start ourselves out with some fairly easy ones. All right. We're going to start out with the parent graph, which is y equals x. All right. But you'll notice that this doesn't really look like that, right? You got some pieces missing. Number one, I don't have anything written here in front of the x for m. So what do we do there? Do you remember? All right. Remember, anytime there isn't a specific number in front of x, it's a 1. It's that sneaky ninja 1. He only shows up when he needs to be seen, otherwise he's invisible. All right. Additionally, how do we say that we've added nothing, right? Because I don't have a plus b here. I don't have a plus b here. So how do I say I added nothing? That's right. We add a 0. So plus 0. All right. So now that we have all the pieces in here, this looks exactly like our slope-intercept form. Let's graph this, all right? So if our 0 is our y-intercept, where does y equal 0? Well, right here at the origin. So we're going to start. Well, then our slope is 1. And what that means, if you'll all remember, this is rise over run. And so 1 as a fraction is literally 1 over 1, which means that I'm going to go up 1 and to the right 1. All right, up and to the right, up and to the right, up right, up right, up right, and I could keep going forever and ever and ever. All right, once I have enough dots, I'm going to actually draw a line. And if I could draw a straight line would be helpful. All right, and that's our graph. That's the parent graph. It literally goes diagonally from one corner of our graph to the other, and that's it. That is the parent function, and it looks like that. Everything else is just variations of this. All right, so let's look at our next one here, where I have y equals negative 2x. All right, once again, I'm missing a piece, right? I don't have a b. So what do we put in when we don't have a b? We write in plus 0. All right, so our y-intercept is going to be where y equals 0, which again is at the origin. All right, then we need to use our slope. So our slope here is this number in front of the x, which is negative 2. So our slope is negative 2, but I want rise over run. So I really need this as a fraction. So how do I write a whole number as a fraction? I put it over a 1. All right, and what this says is negative 2, 1. That means I need to go down. My rise is negative 2. I need to go down 2 and go right 1. So from the origin, I'm going to go down 2 and right 1. 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 And so on. I can also, instead of moving in the negative y direction, I could move in the negative x direction. So instead of going down and to the right, I can do the opposite and I can go up and to the left. So let's go back to my origin. Let's go up 2 and left 1, 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 up 2 and left 1. Do you see how the second set of dots that I made is really just a continuation of the first set of dots? All right, we didn't change what we did by moving in the opposite direction. All right, so now that I've got enough dots, we're going to go ahead and connect these, and that's our line. All right, let's work on our next example here. Actually, you know what? Let's skip it. Let's go to the fourth example because we actually have a fractional slope here. All right, first off, we need to start with our y-intercept. This is where we always start because we have to have a starting point. All right, in this case, our y-intercept is 4. So where does y equal 4? So starting at the origin, I'm going to count up 4 on the y-axis. 1, 2, 3, 4. So that is our starting point. Our slope is negative 2/3. Remember, negative says move down and to the right or move up and to the left. So I'm going to start here and I'm going to go down and to the right. So down 2, remember rise over run. So down 2, 1, 2, right 3, 1, 2, 3, and put a dot. Go down 2, 1, 2, and right 3, 1, 2, 3, and put a dot. Down 2 and right 3 and put a dot. All right, I can also go back to my starting point and I can go up 2 and to the left 3, up 2 and to the left 3, up 2 and to the left 3. And then I can make my line. All right, sometimes we have a linear equation that's given to us in standard form. All right, standard form is ax plus by equals c. All right, if you get one that's in standard form, the first thing you got to do is you got to convert it to slope-intercept form. So you have to, it says, if this is the case, you must convert to slope-intercept form. All right, so let's convert these to slope-intercept form from standard form, and then let's graph them. All right, so first thing we're going to do is I want y by itself for slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So I need y by itself. In order to get y by itself over here, I first have to get rid of my x's. So minus 2x minus 2x, so negative 5y equals, and we're going to put our x term first, so negative 2x plus 20. All right, and then I don't care what negative 5y is. I want to know what y is. So I'm going to divide both sides by negative 5. So that leaves me with y equals, remember, I need to split these guys up here. So negative 2 over negative 5x plus 20 over negative 5. All right, now we've got some simplifying that we need to do here. And I'm going to move this over here so we've got some space. All right. So first off, negative 2 over negative 5. What happens when you have a negative divided by a negative? It makes it positive, right? So let's go ahead and fix that. So I get y equals 2/5 x. Next, I have positive 20 divided by negative 5. So a positive divided by a negative is going to give me a negative. And then 20 divided by 5 is 4. So my final equation here is y equals 2/5 x minus 4. All right, so now we need a graph. So start with my y-intercept, which is negative 4. So start at the origin and count down 4. 1, 2, 3, 4. And then my slope, which is 2/5, which means I'm going to go up 2 and right 5. So up 2, 1, 2, and to the right 5. 1, 2, 3, 4, 5. Once again, I'm going to go up 2 and to the right 5. And then I've got 3 dots so I can draw a line. All right, let's go over to this one. I'm going to do the third one so I've got space to work. All right, once again, I want y by itself, so I'm going to get rid of my x's first. It's being subtracted as a negative 5x, so I'm going to add 5x to both sides. So I get 10y equals 5x plus 20. And I want y by itself, so I got to get rid of that 10. So divide both sides by 10. Moving over here. So I've got some space. So I get y equals 5/10 x plus 20 divided by 10. And now let's simplify. Y equals 1/2 x plus 2. All right, start graphing. Y-intercept is where y equals 2. So y equals 2 right here. And then my slope is 1/2, which means I want to go up 1 and to the right 2. Up 1, right 2, up 1, right 2, 1, right 2, up 1, right 2, up 1, right 2. And now that I've got enough points, I can draw my line. All right, and that is pretty much it for the day. If y'all have any questions, please send me an email. Good luck with your homework. Just kidding. We need to talk about vertical and horizontal lines. All right. Number one, let's talk about what exactly are vertical and horizontal lines. Remembering that horizontal lines go side to side on a paper, and vertical lines go up and down. So horizontal side to side, vertical lines up and down. The slope of a horizontal line is 0. All right, now let's think about this a little bit. Remember that slope is rise over run, right? Does this line rise anywhere at all? Does it go up at all? No, it does not rise at all. It is 0. It rises nowhere. Its slope is nothing. All right, so for these equations, the way you're going to see it with a slope of nothing is going to be a y equals some number. All right. Vertical lines. Well, what's the rise over run here? Well, it's all rise, right? It rises infinitely, but what's the run? Does it go left or right anywhere? No. So rises infinitely, my run is 0. What happens in math when we try to divide by 0? Yeah, your calculator freaks out on you, right? All right, so the slope of these, we call this undefined. All right, so the slope is undefined. Anytime you get a slope that says undefined, it goes straight up and down. It's a vertical line. All right, so the equation for these is going to be x equals some number. All right, so let's look at these. All right, y equals -2. What did we just say a y equals graph was? It's horizontal. So we know this is going to be horizontal. But how do I graph it? Well, let's use the only piece of information we have, right? Y equals -2. So y equals -2 right here. But you know that there's a whole bunch of other points where y equals -2? This is just where x equals 0 and y equals -2. What if x equals 1? Well, y still equals -2. What if x equals 5? Well, y still equals -2. What if x equals 10? Well, y still equals -2. Do you see how this is making a horizontal line? It does not matter what my x value is, y is always going to be -2. All right, similarly, this one is an x equals graph, which we said is a vertical line. All right, it has an undefined slope, and so we need to graph it where x equals 5. 1, 2, 3, 4, 5, right here. Okay, so where are all the places where x equals 5? Well, when y equals 1, x equals 5. When y equals 5, it's still 5. When y is 10, it's still 5. Even if y is like -8, it's still 5, right? So this is a vertical line. All right, what if x equals 0? Is this vertical or horizontal? It's an x equals, so it's vertical. And where does x equal 0? Well, right here, right? So all the points where x equals 0 is actually the y-axis. All right, now that I've scrolled, let's talk about these slopes, right? So horizontal slope, my slope is 0. Vertical slope, my slope is undefined. Vertical slope, again, my slope is undefined. All right, now sometimes we do have to solve first, all right? Because we can't graph anything unless we've solved it. Because 2x equals 8, what? Well, it only has an x, so I know it's gonna be a vertical. But my format for this is x equals something, right? So I wanna get rid of this 2. So divide both sides by 2. So that gets me x equals 4. So then we can graph it 1, 2, 3, 4, straight up and down. So my slope of this one is undefined. All right, next. Look, this only has a y, so we know this is going to be a horizontal one. but we got to solve it for y. So let's add 10 to both sides. So I get 5y equals 10. Then I divide both sides by 5, so y equals 2. So it's going to be a horizontal line where y equals 2. Remember, what is the slope of a horizontal line? 0, because it has no rise, it's all run. All right, we do the same way this way, but without graphing it, let's just look at this. Is this going to be a horizontal line or a vertical line? Yeah, it's vertical because I only have an x. So this is going to be a vertical line. All right, scrolling down. One last question. How do we know it was not possible to put each of those last 3 equations into slope-intercept form? Why was it not possible to put them in slope-intercept form? Well, remember, slope-intercept form is y equals mx plus b. In order for slope-intercept form to work, I have to have a y and an x. Do I have both a y and an x in any of these 3? No. So I can't put them in slope-intercept form because I'm missing pieces. I don't have all the pieces. All right. So for slope-intercept form, you need both y and x. All right. So I actually made it this time. This is it. Good luck with your homework, guys, and email me with any questions. Have a great day.